Hello, in this video we're going to go over problem 3 from the University of Maryland High School Math Competition Part 2. This competition is usually held in December, early December or late November of every year. A right triangle A1, A2, A3 with side length 6, 8, and 10 on a plane P is given. Three spheres C1, S1, S2, and S3 with centers O1, O2, O3 respectively are located on the same side of the plane P in such a way that SI is tangent to P and at AI for I equals 1, 2, and 3. Assume S1, S2, S3 are pairwise externally tangent. Find the area of triangle O1, O2, O3. So we have the triangle at the bottom. It's in fact a right triangle, and on top of that we have three spheres. We have a sphere here, we have another sphere here, and we have a sphere here, and these three spheres are also tangent to each other. So now we don't really need the whole diagram. We're going to focus on portion of the diagram. So let's say the points A1 and A2 are at the bottom, and O1 and O2 are on top here. Now, what is the condition for spheres to be tangent to each other? Well, first of all, the distance from O1 to A1 is radius 1, and the distance from O2 to A2 is radius 2. And for the spheres to be tangent, the distance between the centers would have to be R1 plus R2. Now we know that this side is 6 of the triangle. This side of the triangle A1, A2, A3 is 6. So we can find a relation between R1 and R2 by dropping a perpendicular from O1 to O2, O3. So this is 6, and if you look at this right triangle, one side is R2 minus R1. So we can write down the Pythagorean theorem. We get R2 plus R1 squared equals R2 minus R1 squared plus 36. If we expand this, we get R2 squared plus R1 squared plus 2 R2 R1 equals R2 squared plus R1 squared minus 2 R2 R1 plus 36. So canceling R1 squared and R2 squared, we get 4 R2 R1 is equal to 36, which means R2 R1 is equal to 9. So this is the first equation that we get. Now, if we do the exact same thing for the other two, we get R2 R3 is equal to, so we'll write down the exact same thing. The other side is 8, so instead of 6, we're going to have 8. So it would be 8, 8 squared, and here we have 4 R1, R2 R3. So we get R2 R3 is equal to 16. And similarly, because 4 R1 R3 would be the last side squared, which is 10 squared, we get R1 R3 is equal to 25. Now, let's take these three equations that we got and see how we can find these radii. R1 R2 is 9, R2 R3 is 16, and R1 R3 is 25. So this is a symmetric system, and the best way of solving this one would be to multiply them all together. We get R1 squared, R2 squared, R3 squared, and on the right side we get 3 squared, 4 squared, 5 squared. Getting rid of the squares by taking the square root of both sides, we get R1, R2, R3 is equal to 3 times 4 times 5, which is 60. So that's the product of R1, R2, R3. So now we can get R3 by dividing R1, R2, R3 by R1, R2. So we get 60 divided by 9, which is 20 over 3. R2 would be R1, R2, R3 divided by R1, R3, which is 60 divided by 25, so that's 12 over 5. And R1 is the product, which is 60 divided by R2, R3, which is 16. So dividing the numerator by 4, we get 15. and dividing the denominator by 4, we get 4. So 15 over 4 is R1. So now if you look at the triangle that we have, O1, O2, O3, we have O1, O2, O3. The distance between O1 and O2 is R1 plus R2. The distance between O1 and O3 is R1 plus R3. And the last side is R2 plus R3. So how do we find the area of a triangle when we have the three sides? Well, we're going to have to use the Heron's formula. So for Heron's formula, the area is equal to square root of semi-perimeter minus the sides, and take the square root. So that's the area. So first of all, let's find the semi-perimeter. So semi-perimeter is R1 plus R2 plus R1 plus R3 plus R2 plus R3, but you have to divide that by 2. So it is R1 plus R2 plus R3. So let's take these numbers that we got. 15 over 4 is R1, 12 over 5, and finally 20 over 3. We're going to add them. That gives us the semi-perimeter. The denominator is 60. The numerator is 15 squared plus 12 squared. I'm taking the common denominator plus 20 squared. And this gives me 769 divided by 60. So that's the semi-perimeter. Now, if you look at the semi-perimeter minus one of the sides, which is R1 plus R2, that is R1 plus R2 plus R3 minus R1 plus R2. So it's going to be R3. So that's the semi-perimeter one minus one side. And similarly, semi-perimeter minus the other two sides can also be evaluated. So semi-perimeter minus R2 plus R3 is going to be R1. So finally, we can find the area. The area would be square root of semi-perimeter, which we found to be 769 over 60 times R1, R2, and R3, which are semi-perimeter minus the three sides. And those are 15 over 4, 12 over 5, and 20 over 3. Okay, so 15 and this one cancels to 4. 4 and this cancels to 3. Now we have 3 and 3 cancel, and this 20 and 20 cancel. So in fact, the final answer is going to be square root of 769. And that brings me to the end of this video. So I will see you in the next video.